How do you factor a difference of two squares? In the previous video, which was video number 1, I explained what a difference of 2 squared was and how you can identify it and justify your response to say yes or no, it is a difference of 2 squares. Now I'm going to show you actually how to use this shortcut to factor a binomial, or yes, a binomial. This will help so that you don't have to use the X method. But in class, I have shown you how to use the X method for these next examples. Just a reminder that this is video 2 for section 8-5. Okay, this was from the previous slide, or excuse me, not previous slide, but a previous video, the last video we watched. I had this for you, and this just helps you to determine whether or not it's a difference of 2 squares. So I'm going to give you some examples. We got to first determine if it is a difference of 2 squares, and if so, then we can apply the shortcut, which I'll explain on the next slide. Okay, go ahead and pause the slide, pause the video, make sure that you write down this information, and then replay it when you're ready to follow along. The difference of 2 squares. This is the explanation of difference of 2 squares using just variables. If you have a squared, which is a perfect squared, and b squared, which is a perfect squared, then you're going to have a difference of these 2 squares. The difference in this case is the subtraction. When that happens, to factor this difference of 2 squares, you're just going to do 1a plus 1b for the first binomial. That's multiplied to the second factor, or the second binomial, which would be a minus b. So they gave me an example using some numbers. You have x squared minus 9. I'm showing you how to factor that using the X method, but now you can just apply the shortcut. Split the 9 into 2 equal factors, 3 and 3. Then you'll do x plus 3 and x minus 3, and you're done. Okay, let's go ahead and apply the concept now, the shortcut. I don't have to use the X method for these problems. I can just factor them using the difference of 2 squares. So let's first determine whether it is a difference of 2 squares, and if so, we'll factor it. So we're going to check to see if x is a perfect square, x squared is a perfect squared, and it is, right? X times x would give you x squared. And then 49, let's see if that's a perfect squared. It is. It's also on that table from the last video. So that's 7 times 7. Now that we have checked to see if it is a difference of 2 squares, we can apply the shortcut. So here we have x plus 7. Remember, I take 1x and I add it to a 7. Then I take 1x and then I subtract 7. And I'm done. So quick and so easy. It's a great shortcut, and it really helps with your time management. So here is our answer, x plus 7 times x minus 7. To double check it to see if it's correct, you can just use the box method or the distributed property, and you'll get x squared minus 49 back. Okay, here's our second example. We're going to determine whether it's a difference of 2 squares, and if so, we'll factor it. So x squared can be split off into x times x. Easy. And then 121 can be split off into 11 times 11. And notice it has the subtraction in the middle. If it was a plus there, we couldn't apply this. We could not apply this shortcut. It has to be a difference of 2 squares. And now we'll write it out in a factored form. So x plus 11 and x minus 11. Now we're done. Let's go ahead and try some more complicated examples. Okay, here is one. Notice we got a number, a coefficient in front of the variable x squared. And we even have an extra variable y to the 5th. So we're going to determine first if this is a difference of 2 squares. That means I need to split both into equal pairs and equal factors. So I can do this one as 4x times 4x, right? 4x times 4x is 16x squared. But then when we take a look at the 4y to the 5th, the 4 is fine, right? I can split that off into 2 times 2. However, y to the 5th cannot be split off into even factors. Y to the 5th can be split into y to the 1 times y to the 4th. That would give me y to the 5th, but they're not equal exponents. Y squared times y to the 3rd would give me y to the 5th, but it has to be the same thing. So since there are no combinations to use for the y's, this is not a difference of 2 squares. And we cannot factor it using the shortcut or using the X method. Okay, here's our last example. That's a little challenging. We're going to determine whether the binomial is a difference of 2 squares, and if so, we'll factor it. So p to the 8th can be split off into even factors. Notice the exponent has to be even, huh? The last example, the y exponent was 5. That was an odd number, so it can be split into equal pairs. But 8 can. It could be p to the 4th times p to the 4th. And then for the second monomial, we have 7q to the 3rd and 7q to the 3rd. This is a difference of 2 squares, so I can apply the shortcut and factor it. So we get p to the 4th, and remember we're going to add, so I get 7q to the 3rd. And then the second binomial would be p to the 4th, and we're going to subtract, minus 7q to the 3rd. And it's fully factored. And you can use the distributive property or the box method to check your work.